Great. So let me just so I'm just going to chat with everyone. I'll just wait to see if people join. So yeah, I can see that we've got some attendees. Hi, good morning. My name is Kim. I'm the Outreach and Communications Coordinator at UCL Biochemical Engineering. Could you do me a favour? Thank you for joining us. Can you just put a yes or a hello or something in the chat box? Yeah, I see we've got a couple more people joined. Could you just put yes or something in the chat box? It means that I know that the audio is coming through. It means I also know the chat's working as well, which is really useful. So if you can hear me, just type a yes in the chat box. It's one of the features you've got at the bottom of the screen there. So just wait to see if somebody can do that. So just check. So, right, yes, there we go. So it's always worth checking. So if you can check now if the chat's working, just put a yes or a hello. Brilliant, thank you very much. This is why we always check these things. We've learned through hard experience to always check everything. Good morning, a very warm welcome. I hope you're having a great day. For us in the UK here in London, it's first thing in the morning, first start of our working day. As I said, my name is Kim Morgan. I'm the Outreach and Communications Coordinator here at UCL Biochemical Engineering. So we'll wait a few moments for everyone to join, but whilst we're waiting for everyone to join, and before we really start going properly, I'm just going to introduce the platform and explain how it's going to work. So I'll talk you through the system. This is being recorded. Everyone who's registered will get sent a link afterwards to be able to watch this back. So if you miss anything or you'd like to review it, you will get sent a link afterwards to record it, to watch the recording. There are also some people who've sent questions in who won't be able to join in person. I'll read those out at the end. If you have any technical problems, if you can't hear us clearly, please let us know in the chat. Myself and Petra will see that and we'll endeavour to solve your problems. If you have any questions, I mean, we're a relatively small group, but you can either put it in the chat or put it in the Q&A box. What's very useful about posting questions in the Q&A box is that we can see them all at the same time rather than the chat box. And maybe if sometimes people ask a question to which the most useful response is that I'll go off and find a link and find some text. It's easier to put that in the Q&A, but quite frankly, we'll answer both of them. So what I'm going to do is I'm going to hand over to my colleague, Dr. Petra Hanga. Petra will give a talk about the MSc Biochemical Engineering, and then when we come to the end, we'll answer your questions. You can post them at any point throughout the talk. Quite often, we come to the end, we find that some of them will have been answered, or some of them are thematically connected. So it's really just put them in the Q&A box as we go along. Petra, and if I turn my camera off, it's just so you can concentrate more on Petra. I will be here in the background.
Kim, can I share my screen?
Yeah, absolutely. Let me just make sure that that's.
Yeah, let me just try and see.
There we go.
Okay, can you see that just to confirm?
Yep, that's coming up.
Okay, perfect. Right. So, hello everyone. Good morning, good afternoon. I don't know what it is where you are. My name is Petra Hanga. I am an academic at UCL in the Biochemical Engineering Department, and I'm also the program director and the admissions tutor for the MSc in Biochemical Engineering. So it is my absolute pleasure to give you a bit of insight into our program so that you know what to expect if you do join us. Welcome to UCL from everyone, from all the staff. UCL is one of the top world universities, as you're most likely aware. It has been voted University of the Year in the News Time this year. So, it's a university with a lot of prestige. We are in the center of London, in the heart of London, and this is just a snapshot of our main quad. And you can see, on a very nice day, very sunny day, which does happen in Britain as well. So we do get quite a few of those. So in terms of the biochemical engineering MSc program, because we're here to talk about this, I'm going to give you a bit of insight into what to expect, what you will learn, what makes it unique compared to some of the other programs. And then I'm going to go a little bit through the curriculum. I'll show you a few pictures because as you will learn, this is a program that is very, very intense. So you will have to put in a lot of hard work, but it also has a lot of opportunities for fun and for socializing. And I'll show you a few of those images that we've had between students, MSc students, undergrads, but also staff. So we do like our social events very, very much. So this program, as the name suggests, is focused on giving you the necessary skills to become a biochemical engineer. And what biochemical engineers do is that we translate innovation and discoveries in the life sciences from the bench scale, so the lab scale, to industrial scale, to actual processes and actual products that consumers, or if we're talking about foods or people, get to experience and get to benefit from, if we're talking about medicines. So what you will learn in this program is all about developing those skills to become a biochemical engineer. So you will learn things like advanced engineering, bioprocess design, bioreactor engineering, downstream processing, which refers to purification of products or separation of products. You will also learn about various life science analytical techniques and applications of biochemical engineering. So things like vaccine development. There is a specific module which for some of the routes is optional, for others is core, where you get to learn about how to produce vaccines. You'll also learn about things like microfluidics, which can be useful in certain applications, molecular biology, etc. And then there's also the option of learning a little bit through one of the modules that we offer, learning a little bit about entrepreneurship and commercialization of these type of products that you will learn about how to make, right? I mean, it's very important to have a little bit of understanding in that area as well. So what makes our program unique compared to some of the similar bioprocessing engineering or biochemical engineering programs in the UK and actually in the world is the fact that we have designed this program to suit not only engineering graduates, but also science graduates. And we have done that by taking into consideration the background, right? The undergraduate background that you're coming from. So if, for example, you come from a science undergraduate degree, you will be assigned to the 4 scientist route, which will teach you all the engineering knowledge that you need to come at the same level as a biochemical engineer. So one thing that I haven't mentioned is that biochemical engineers sit at the interface between life sciences and engineering, which gives us a very unique set of skills. So in order to get those set of skills, you need to get knowledge, you need to gain knowledge and understanding from both science, but also engineering. So by taking students that have a scientific background, we equip you with the engineering skills that you need. And we do the other way around for the engineering background students. We give you all those other skills that focus more on the science, more on the application, to get you to the same level. And that's the goal of the project. At the end of this one very intense year, you will all be at a similar level in terms of your knowledge of biochemical and bioprocess engineering. Our program is also very unique because it gives you access to our actual very unique industrial training courses, and this is specific to UCL. We have established these many years ago through our program of modular training for the bioprocess industries. Our biochemical engineering department is actually the largest department in the world that focuses on bioprocessing as well. So obviously, this is the place to be if you want to become a bioprocess engineer. So in these industrial training courses, in the MBI courses, through some of the modules that you will be taking in the MSc, you will also be taking these MBI courses. And I think for one of the routes, you have access to 2 of them, and for the other one to 3 of them, if I recall correctly. But essentially what these are short, intense courses of a couple of days or a week, where you get the opportunity to sit next to people from industry coming to learn these skills on specific aspects of bioprocessing. And our program is also unique because we are accredited by the Institution of Chemical Engineers, which is a professional body that standardizes training and creates standards for the chemical engineering industry. So this is very important because this speaks to the standards of training that we offer through this process, through this program. And that also means that actually at the end of the program, you will have, depending on the route that you're coming out of, you will have a route towards professional accreditation with the ICME. Okay, so in terms of entry requirements, you're probably familiar with this already. A minimum of second-class honors degree from either a UK university, or if it's overseas, an equivalent of this is required. And as I said, we take both science degrees and we take engineering degrees. And then obviously, of course, because this is an engineering focused degree, we do require evidence of numeracy. So anything like, for example, an A-level mathematics or calculus or anything like that will be taken as that evidence of being able to carry out mathematical analysis. And then, of course, UCL has the language requirement, which you can find all about it on our prospectus. And I think Kim can put the link in there to have a look at it. Because I've mentioned that there are 2 routes to this program. For scientist route will take students with a background in a scientific degree. So that can be biotechnology, biochemistry, bioengineering, biology, applied biology, molecular biology, so anything like that. And then for engineers route, we take students with a background in an engineering degree, chemical engineering, mechanical engineering, even electrical engineering. And then within the for engineers route, for those of you that come from a biochemical engineering or a bioprocess engineering background already, we have a separate pathway which we call, which is called the advanced biochemical engineering, and this will focus more on applications. So the modules that will be taught and will be core in this module will be all about applicability. Okay, so in terms, I did put here a little star because myself as the admissions tutor, I do the allocation for the different routes based on your transcript. So for those of you that come from engineering degrees from overseas, obviously the structure of engineering degrees can be a bit different from university to university. So generally, when I do the admission on the 4 engineers route, as part of our accreditation, I need to ensure that you have taken modules that are linked to the core chemical engineering principles, and that means modules such as fluid flow, mixing, thermodynamics, mass transfer, and there has been an element of design. So only if you have these modules in your transcript, that is when, or you can demonstrate that you've done all of this, that is when you will be allocated to the 4 engineers route. Okay, so in terms of the program structure, this is what I've just mentioned, but it's a bit more visual, so hopefully it gives you a bit of a better idea. There are 2 routes, the 4 scientists and the 4 engineers, and within the 4 engineers, there is the pathway of advanced biochemical engineering, and this basically says exactly what I've just said now, what kind of degrees are suitable for each of the routes, and then what you will be learning in each of these routes or pathway. And this is to give you a bit of an idea of the curriculum for each of the routes. So for the scientist, you would have core modules or compulsory modules that focus on the engineering aspects, like I've said, because you have the scientific background, but now you will have to learn the engineering elements. So you can see modules like fluid flow and mixing, bioprocess synthesis and process mapping, which is actually a module that I'm the module lead of, so I would be teaching that. Integrated downstream processing, and then some of the more advanced engineering, like advanced bioreactor engineering, heat and mass transfer, validation and quality control. And we have a specific module dedicated just to practical skills. So this is the Biochemical Engineering Laboratory that will give you the hands-on experience in the lab on techniques and analytics that are key for us as biochemical engineers. And then for the scientist, as part of our accreditation requirement, you will have to undertake a bioprocess design dissertation. And these are the optional modules for the scientist. So you can choose between commercialization of research ideas. So that module that I mentioned, that it gives you a bit of a understanding or a little bit of knowledge in what it takes to commercialize an idea. Or you can choose sustainable industrial bioprocesses and biorefineries, or the other one is advanced safety and loss prevention. And then for the engineers, you will learn some of the advanced engineering elements, which you wouldn't have done in your undergraduate degree, plus more of the scientific knowledge and application. So you can see you have modules like integrated downstream processing and advanced bioreactor engineering. These will give you the advanced engineering knowledge. But then you also have modules like fundamental biosciences to give you that understanding, or in sustainable industrial bioprocesses and biorefineries. And the biochemical engineering laboratory module, this is basically common throughout all the routes and pathways, and this is what will give you that hands-on practical skills. So the engineers, because you already would have had a design element in your undergraduate degrees, you don't need to do the design again, which is the condition for the ICANI accreditation. So you will do a bioprocess research project, which is inspired by research undergoing in our own department. And one thing that I forgot to say with the dissertation, with the design dissertation, is that generally the design that you will have to do will be linked to useful products or products that are of let's say hot topic at the time. So for example, last year it was all about vaccine development. I don't know what Professor Dan Bracewell, the module lead, will be doing this year, but probably something similar, or a hot topic of the year. And then in terms of the optional modules for the engineers, you can choose an optional in term 1 and an optional in term 2. And the pool of modules that you can choose from. So in term 1, you can choose between vaccine bioprocess development, industrial synthetic biology, or biomicrofluidics. While in term 2, you can choose between commercialization, validation and quality control, or energy systems and sustainability. And then for the advanced biochemical engineering pathway, you can see this is more because at this stage you will have had all that engineering knowledge and also understanding of the bioscience. So now is more about applicability. So you can see you'll learn about vaccine bioprocess development, industrial synthetic biology if you're allocated to this pathway, biomicrofluidics, and then the laboratory stays. And of course, because you're within the 4 engineers route, you wouldn't have to take the design, but instead you would take a research project. And then some optional modules, which again focus on applicability. So you can see things like waste and water and wastewater treatment, energy systems, and sustainability or environmental systems. Right, so some of the program highlights, and I've mentioned this a little bit already, the BEng 0096 module, which is the Biochemical Engineering Laboratory module. And this basically is a very intense 3 full weeks that are spent in the lab. And there are different themes in terms of what you would be learning in the practicals in each of these weeks. So for example, in one of the weeks, it is all about bioreactors and how do you operate them, how do you prepare them, how do you sterilize, prepare media, etc., measure, all of those things. In another week is all about pilot plant. So you will get to work at scales that resemble the industrial scales, the industrial factories. So yeah, so you would be, in this module, you would be making use of our state-of-the-art facilities and laboratories. And you can see here a few of the type of investments that we have done in our laboratories. I mean, we have the Advanced Center for Biochemical Engineering, which is a 25 million pounds facility. So any analytical equipment that you can imagine that is relevant to bioprocessing, we pretty much have it. And our state-of-the-art facilities within our department are very much linked to the research that we do. So we are a very research-intense department. And actually, UCL in general is very research-intense. And we are associated with several manufacturing hubs on both vaccines, on future therapeutics, and more recently on cellular agriculture, which is essentially in the space of alternative proteins. And then this is the modular training for the bioprocess industries that I have mentioned. And you can see some images that were taken. So some of these MBIs also have a practical element to them. Others are more based on lectures and workshop seminars type of approaches, but essentially you would be sitting next to industrialists, learning, and you would also be learning from people from industry that have a significant number of years of experience. So these modular training courses have been designed and are delivered in collaboration with industrial experts, and are making use of our very wide connections with industry, because what we do as biochemical engineers is very applicable, which means that to get that impact, we do have to work very closely with industry. And I thought I would include this in here as well to give you a bit of an idea of where our graduates from this particular MSc in Biochemical Engineering program end up. And this was based on a data from, I mean, it's slightly older, but it still applies from 2017 till 2020. It still applies even now. The majority of our MSc in Biochemical Engineering graduates end up in highly skilled work, and actually quite a large proportion of them end up working in industry. We also have some of our MSc graduates end up doing PhDs within the department. So they stay along in academia. Some go and do things like consultancy, and a very, very small percentage of our graduates is unemployed, or at least it was unemployed at the time of the survey. As I said, it will be an intense program, but you will learn a lot. You will make a lot of connections as well. You have opportunities to network not only with your peers, but also with people from industry. These are just some images to kind of give you an idea of the type of things that you would be doing. This is actually an image from one of the weeks during the practical, where you can see she's working around a bioreactor. Then this is in the pilot plant. So it's hard work, but it's also very fun. So there's a lot of opportunities for socializing with students and staff. But excuse me. And I think our general advice is to take all these opportunities and get to know the staff better, get to know your colleagues better as well. We do have at UCL quite a lot of societies, and actually in the department as well, we have several student-led societies, and they always have things being organized. They always have events, like for example, now at the end of November, there's the Christmas ball that's coming up. And everyone is invited, undergrads, masters, students, staff, etc. So so definitely, take advantage of all of these opportunities. And that's it from me. So I can see there's quite a few questions that have come through, and I'm happy to start addressing these now. So I'm going to stop sharing my screen now, and then we can focus on the questions.
Sure, I've got one which was sent in, but before we go into the questions, I just want to do a bit of a plug. Every year we do a series of taster lectures online, and this year we've got another really exciting series of webinars that we're doing. We'll be covering vaccine manufacture. We're also doing a really exciting one, which is going to be on autoimmune diseases. So we're going to be doing one on lupus, and that's me with Dr. Thomas McDonald. That's a really exciting one. That's covering our sort of cutting edge research, which a lot of people wouldn't necessarily associate with biochemical engineering. But Petra is going to be presenting one on lab grown food, and they've been really popular over the last few years. So before the end of this session, I'll put a link in the chat. Do sign up for it, do join us for that, and keep an eye out for the rest of the sessions. They're always really good fun, and they cover the really wide variety of things that we do here, from stem cell and gene therapy to growing artificial meat. So what I'm going to do is that one of the questions that we have posted was from somebody who is doing they're doing an MSc, a BSc program in biochemical engineering. And it's one of the degrees that we've actually got here in our department, and it is, sorry, my email box has gone up to the side of the screen, just bear with me. So the question is that they're doing the BSc Bioprocessing New Medicine Science and Engineering, And what they envisage doing is going on to do one of the UCL EPSRC doctoral projects. Petra, it might want worth saying a word about what that is. But she was asking, should she do an MSc in biochemical engineering to bridge her between that? And I think it's just useful to talk about why people go on to do MSCs and why people go on to do MSCs and how that can prepare you for a PhD if that's what you want to do.
Yeah. Yeah, that's actually a really good question. So we do have coming up, we recently started advertising our doctoral training PhD studentships. These are funded by the EPSRC, so they do have an element of engineering to them. And these are full scholarships for ambitious students that want to start doing a PhD. And actually we have quite a few, I think, we're around 12 now, if not more, that are advertised for our department specifically, never mind everything else. I have one on there as well. So yeah, so definitely check it out. But I think from my point of view, because a PhD is a very, well, it's an investment, right? It's an investment of time. It's an investment of effort. At the end of a PhD, you get not only a PhD degree, but you know, it's quite difficult to put a PhD in a category because it sits somewhere in between a degree and a job, right? But it's not a job because you have to really work for it to get a degree at the end of the day. And having certain skills to prepare you for the PhD, I think is very, very useful, especially if you're coming from an undergraduate degree where you haven't you're missing one of the elements within that specific PhD project. So think of PhD projects as being very, very specific to a certain subject, right? And most of the times they are multidisciplinary, meaning that you need knowledge from different areas. So for example, if your undergraduate degree is in from a scientific background, but you're missing and you want to apply for a PhD in bioprocessing, you're obviously missing some of those engineering skills. So that would be a good opportunity for you to, for example, do a one-year master's so that you can develop some of those skills that you're missing, and that will make you more prepared for a PhD. Is not necessarily a requirement to have a master's level degree for a PhD, but it can help you in getting you more prepared for what's about to come. Yeah.
Great, thank you. Just in answer to someone who's asking some questions about the PhD programs. I've sent you my email address. I've posted it in the chat as well anyway, but I'll be happy to take that up further with a different team. I mean, we are talking about the MSc program here. I can go into a lot more detail if you email me directly, and I can address your personal circumstances and make sure that we get you a proper answer. So do come back to me offline about that. There's a question that's come up. I'll read it out to you if it's all right, Petra. In fact, it's actually in three parts. The second part is there a waiver for the English requirement for countries with English as a medium instruction? What I'll do is I'll send you a link to the prospectus, because there's a whole load of information in the prospectus about how that works. So it's probably easier to do that in text because it's all written out. But the first question is chemistry undergraduate degree accepted? And then there's another question about funding options. So Petra, over to you.
Yeah, so obviously chemistry is a science based degree, so we do accept that. That is accepted. If you come from a chemistry or biochemistry degree, you would be allocated to the for scientist route. Yeah. And then in terms of funding options, we don't have a we don't have a scholarship for the masters. At least not one that I'm aware of. I don't know, Kim, if you're familiar with anything else. We do have scholarships for PhDs, but not for masters, unfortunately. So yeah, so I don't really know what to say on that. I don't know what to advise you on that.
We don't have any specifically for our MSCs, but there are there are ones that span UCL. So what I'll do, again, I'll put this in the response to the question. Have a look at the prospectus entry because it'll have links there to funding opportunities. I think one of the reasons for this, though, is depending where you're coming from in the world, there are specific funding opportunities available to people in that country. So it's a really difficult one to cover. So, for example, you'll find there are certain funding sources that are only available to people in the UK. Likewise, if you're coming from, say, South America, you know, I know Brazil has specific funding for Brazilian students. So it's a very, very big question, one that we certainly don't have the answer to here. But have a look at the link and follow that through there. I'll just pop that in the chat now. Okay, so those are all the questions that have come through now. What I'll do is, if I just hand over to Petra briefly, just to talk about if you just mentioned the Spring into STEM taster lecture, give another plug. I'll put the link in the chat, and then although right, there's a very big response coming to here.
Oh.
Yeah, the person who's just sent this. What I'll do is I'll put my email address because it sounds like we need to have a conversation about your specific situation. I don't really want to discuss it in a forum with other people. I can see you've given us a lot of information there. I'll give you my email address, send that to me directly, and I'll be happy to pass that on and we'll look at that for you. So I'll just put that in the chat now and go quiet for a moment whilst I'm typing.
Okay. Yeah. I mean, in the meantime, I can talk about the STEM into spring. So every year, I think it's been for the past 3 or 4 years now. In the spring times, around April time, we do organize taster lectures based on the type of research that we do in the department and actually within the Faculty of Engineering. So one of these taster lectures will be based on my research, which is on lab-grown foods. So I do a lot of research in the cellular agriculture space, which is basically making animal-derived products without having to slaughter the animal by using biotechnology. So yeah, so I mean, definitely join us for this. We do record those taster lectures as well, and they are available on, is it on YouTube, Kim?
Yeah, what I'll do is, because I know not everybody can watch YouTube, so anyone who signs up to it will get sent a link to watch back on Zoom. And then we'll also publish it on YouTube as well, so it's available to people who didn't even.
So yeah, so actually, if you can access YouTube and find UCL Biochemical Engineering on YouTube, you should be able to see some of the previous years ones, so they can get a taster of the type of research that we do within the department. And as Kim said, it varies quite a lot because obviously bioprocessing can be used in any type of application, from foods, which is what I do, lab-grown foods, to vaccines, to therapeutics like cell and gene therapies. So yeah, there's a lot of very exciting and very innovative work that is going on in our department. And as I said, for those of you that will be allocated to the 4 engineers route, so you come from an engineering background, you will be getting a taste of that type of research through the research projects that essentially are inspired from the research that we do within the department.
Fantastic, thank you. Okay, I mean, we've got a few minutes if you've got any more questions to ask, but but we seem to have covered everything, which is great. I'd also like to say, if there's a question that you didn't ask, there's something that you really want to post, you please get in touch with me. I'm more than happy to field questions from people. if you want to have a discussion about what we've done here, I have to say the Spring to Stems have the really vibrant questions at the end as well, so it's well worth joining in for those. But in the meantime, thank you very much for giving us your time today. If you're watching the recording, thank you very much for watching back the recording, and I really hope to see you in person at UCL at some point in the future. Petra, thank you very much, and I hope you have a great day.
Yeah, thank you, everyone. Take care.
Bye bye.
Bye.